In this video, I am discussing different questions related to different topics where a lot of strategies are involved. Let us consider the first question. Here, this particular equation 4x square plus 6x plus 4 into 4y square minus 12y plus 25 equal to 28. So this equation, it's only one equation, but two variables are there. One is x, other is y. So solving is directly not possible. So there must be some strategy to solve this equation. This I can write 2 times 2x into 3 by 2. I added and subtracted. Similarly, the second expression 9 plus 16, which is 28. This I can write 2x plus 3 by 2 whole square plus 7 by 4. Here it is 2y minus 3 whole square plus 4 square, which is 28. But LHS, it is greater than 7 by 4 because it is also greater than 0. It is greater than 4. LHS is greater than 7 by 4 into 4. 7 by 4 into 4 square. So that is 28. But so always greater than or equal, but we want equality. That is possible only for a case where this 0 as well as 2y minus 3 0. That means minus 3 by 4 comma 3 by 2. There is only one ordered pair which satisfies the equation. Here in this, sum of all the real values of x satisfying the equation. A power b is 1. There are many cases. A is 1, b is any number, or a is not equal to 0, b is 0. And another possibility, a is minus 1, b is even number. Case 1, if you take x square minus 5x plus 4 is 5 is 1. That is x square minus 5x plus 4 0. Here you have two solutions, 1 comma 4. Case 2, if you take power 0, that is x square plus 4x minus 60 0, x plus 10 into x minus 4 0, x is minus 10 comma 4. So for these values you must see that base is not equal. Obviously 16, if you take 4, 16 minus plus 5 21 not equal to 0. Similarly, for negative anyhow it won't be 0. So both are the solutions. Case 3, x square minus 5x plus 5. So x square minus 5x plus 6 0, 2 comma 3. For these values of x, b must be even. B in the sense power. Let us take power here is x square plus 4x minus 60, which is x plus 10 into x minus 4. If you take x as 2, it is even number, okay. X is 3. If you take 13 into minus 1, odd number, this is ruled out. So finally, solutions are x is 2, minus 10, 4, 1. Here it is, this is 6, right? So here it is 6. So sum of all the solutions, 2 minus 2 plus 4 plus 1 plus 6. So here it is 7, 11, 13 minus 3. Sum of all the values of x. Here, z minus 25. Z is any complex number. So let us do by geometry. Here it is 25i in the sense 0 plus 25i, which represents a point 025 in the complex plane. So z is any point on the here mod of z, you know, that which represents a circle. Mod of z minus z naught less than or means represents of points inside a circle. So here in the given expression, z minus 25 is 15 means center here is 0 comma 25 and radius is 15. So now so this angle is theta. This one is here the minimum of arc z. What does it mean? So here if you take a complex number z, argument will be angle made by the OP line with the x-axis. Here you have different points. So this point argument, so different points will have different arguments. If you take a circle here, this point argument is this, right? This point argument is this. This point will have a least argument. So here I will write least argument. This indicates many complex number. Among all the complex number, one particular complex number z will have a least argument that is possible when OP is the tangent. So argument of z here is that least argument is alpha. So then this becomes 90 minus alpha. Now to have a greatest argument, this particular complex number will have a greatest argument. Right. So this one is also 90 minus alpha. So maximum of argument of z will be, here it is alpha plus 90 minus alpha plus 90 minus alpha, which is 180 minus alpha. So maximum of argument of z minus minimum of argument of z will be 180 minus alpha minus alpha, which is 180 minus 12, which he defined as theta. Then here cos theta will be theta by 2 will be cos of 90 minus alpha, which is sin alpha. Yes, here it is, this is radius is 15. So cos sine of 90 minus alpha is 15 by 25. That is cos alpha here is 3 by 5. Sin alpha will be 4 by 5. 5 cos theta by 2 will be 5 sin alpha, which is 5 into 4 by 5. It is the answer. This one, so by C, Z means it represent a arbitrary point. One means a fixed point. Here you have two fixed points. So once you take ellipse, here these are two fixed points. One is minus 3, 0. Geometrical property, P is any point on the ellipse. Then you have SP plus S dash P will be, here P represents Z. So SP means Z minus 1 distance. Modulus of difference of complex number will give you distance. S dash P means Z minus 3. Here it is, I will take it as 8. Less than indicate point inside the ellipse. Equal to indicates point on the ellipse. Here it is, 2a is 4. Sorry, 2a is 8. A will be 4. So this is the center. And the midpoint of minus 3 comma 1, minus 3 plus 1 by 2, 0 plus 0 by 2, which is minus 1 comma 0. This is minus 1 comma 0. Right. And here it is, distance is the A in the sense for an ellipse, it is semi-major axis. This is A for us. So A is 4 means here minus 1, 3 comma 0. So minus 1 to 3 will be 4. But he is asking maximum and minimum value of Z minus 4. So now what geometrically it represents, we got an idea. This is major axis. Here it is 3 means. Four will be somewhere here. Why I'm considering 4 means he is asking Z is any point. There are many points, many distances possible. Least distance is, if you consider this point, this will be the least distance. Minimum of Z minus 4 will be how much? 1. Here is a point. So this distance is 8 plus 1, 9. So is maximum distance will be PB. So here is a Z minus 4 will be maximum. In the question, so maximum A is maximum, that is nothing but 9, and B is minimum, which is 1. He is asking B minus A, that is 1 minus 9, which is 8. Here 1 factorial, 3 factorial is 6, 4 factorial is 24. 6 factorial onwards, everything ends with 0. So we don't require which ends with 0. So here if you add 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial, 10, 12, 13, 32, 33 we get. So that is 33 power 2011. Because to get a digit in the units place, we want unit digit. For finding unit digit, this tens digit also useless for us. So the units digit of 33 whole power 2011 is same as units digit of 3 power 2011. As we know, 3 power 4 is 81, ends with 1. Any power of 3 power 4 ends with definitely 1. So I'll write multiple of 2011 as multiple of 4. 502. You'll get here 2008 into 3 cube will give you 2011. This anyhow ends with 1 into 27, which implies units digit in that expansion is nothing but 7. Here number of terms. Suppose if you consider a plus b plus c whole square, you'll have a 6 terms. A square plus b square plus c square plus 2ab plus 2bc plus 2ca. Total you have 6 terms. They are nothing but solutions of this equation, like 2, 0, 0, that indicates a square. 0, 2, 0 indicates b square. So 1, 1, 0, that is indicates AB. 0, 1, 1 indicates BC. 1, 0, 1 indicates CST. That means to get, so terms of this expansion, it is enough to find integral solutions of this. But he given in this, all 3 letters must appear. That is very important. So suppose if you consider only A is there. So here, first of all, we have to find solutions of this equation containing all 3 letters. That means A must start with 1, B must start with 1, C must start with 1. But we have a formula x2 plus xr equal to n, number of solutions n plus r minus 1 cr, n provided each variable is greater than or equal to. If it start with 0, we have this formula. But here it is starting with 1. I will take A as x1 plus 1, B as x2 plus 1, C as x3 plus 1. Then when A start with, because this formula I can't apply to this straight away. When each variable start with 0, I can apply. So I'm writing here x1 plus 1, x2 plus 1, x3 plus 1 is 20. x1 plus x2 plus x3, which is 70. So when a start with 1, x1, 1 get cancel x1. Here x1 greater than 0, x2 greater than 0, x3. Now I can apply this formula 17 plus 3 minus 1, 19 C2, 19 into 18 by 2. Totally you have 171 terms. Here, to calculate remainder of this, when it is divided with 32 per 32, if you take this, I can write 33 minus 1 per 32. Suppose here if you write 3 minus 1 whole square, simply I can write 3 square minus 2 into 3 plus 1, which is nothing but multiple of 3 plus 1. In same way here I can write after expansion it is 3 times multiple minus 1 power 32 is plus 1. So 32 power 32 power 32, which this whole thing I can write it as 3 multiple plus 1. So we are dividing with 7. I will write it as 7 times 4 plus 4 per 3 multiple. So here suppose 7 plus something whole square, 7 square plus 2 times 7. I get 7 multiple plus 1. I will get here 7 multiple plus 4 power 3m plus. This part is anyhow divisible by 7. We have to look into this. 4 power 3m plus 1, I get 4 power 3m into 4. 4 cube power m into 4. It is 64. 63 plus 1 power m. Here, this whole thing I can write. This is a 7 multiple plus 1. Right? 63 contains 7. So each term is divisible by 7 except last one. 28m plus 4. This part anyhow divisible by 7. So the remainder is 4. Here it is. It seems to be a typical equation because one side algebraic and step function, other side trigonometric, directly solving is difficult. There must be some strategy for it. So one simple logic, if you observe, step is an integer. So 8 into integer plus 4 into integer. That means a multiple of 8 or multiple of 4, it is even integer. Whereas RHS, if you consider 12 times sin x, which is 13 plus, right? So this is odd. 13 is odd. 12 times something is even. Odd plus even is odd. So even cannot be equal to odd, whatever may be the x value. So answer is no solution. That means number of solutions. If we ask, we'll write 0 solutions. So in this case, sin x plus sin y, I can write 2 sin x plus y by 2, x minus y by 2, 2 sin x plus y by 2 cos 2 is anyhow non-zero number. I can cancel. I can't cancel this. It may be 0. So we have to take common cos x by 2 minus y by 2, cos x by 2 plus y by 2 0. So here product 0 means a0 or b0, not end. So from here I can say sin of x plus y by 2 0 or cos x by 2 minus y by 2 minus This you know it. So when on result cos difference minus cos sum will be, from here I can say sin x by 2 0 or sin y by 2 is 0. So from here I can say sin x by 2 is 0 means x is right. X by 2 is n pi. X is 2n pi. That means x values are 0, 2 pi like this, 4 pi minus 2 pi. But here if you take x as 2 pi, it exceeds 1. So these are can't be the solution. So x is 0. Substituting in the equation, we get mod y becomes 1. That means y is plus or minus 1. From here I can say you have two ordered pairs as solution. Similarly, y0, you get x as plus or minus 1. You have two more solutions. So finally here you have in two distinct cases, you have totally four solutions. In one more case is that this case. So when x plus y by 2 is 0, that is y is minus x. Mod x plus mod minus x is 1. 2 mod x is 1. Mod x is half. That means x is half or minus half, which implies half comma half is one solution, minus half comma half. So you have totally 6 solutions we have, right? Number of solutions. This one, we have to observe a general term 2, 4, 6. They are even multiples. Here it is 1 is fixed everywhere. 1, 2, 3, these are changing. I will write a general term 1 minus r square plus r power 4. So generally whenever tan inverse is there, we have to write tan alpha minus tan beta by 1 plus tan alpha tan beta. Right? Now this product, from this product you should get these two terms. This I will write it as 1 plus r square. If you take common, r square minus 1. This I will write it as r into r minus 1, r into r plus 1. So this general term I will write tan inverse r square plus r minus r square minus r by 1 plus r square plus r into r square minus r. So it is of the form tan A minus tan B by 1 plus tan A tan B. Tan inverse, this I will write tan of A minus B by assuming tan A as r square plus r, tan B as r square minus r, which is A minus, which I can write tan inverse r square plus r minus tan inverse r square minus r. Now its k is in fact sigma. R runs from 1 to infinite. If you take R as 1, you have tan inverse 2 minus tan inverse 0. R as 2, tan inverse R into R plus 1, 2 into 3, minus tan inverse 2 square minus 2. That is 2. R is 3. Tan inverse this we can write R into R plus 1 minus tan inverse R into R minus 1. Here you take R as 3, 3 into 4 minus tan inverse 3 into 2. Like this you have all these terms get cancelled. Finally, if you take n, tan inverse n into n plus 1 minus. So sum of n terms will be finally what left over n into n plus 1 minus tan inverse 0. This is sum of n terms. But he said up to infinity as n tends to infinity, n into n plus 1 tends to infinity, tan inverse n into n plus 1 tends to tan inverse infinity, which is pi by 2. So finally it is pi by 2 minus 0. So k value here is pi by 2. Then here what you have to find out is 11k by 3. 11 by 3 into pi by 2. So step function 11k by 3 will be roughly get cancelled 3.1 for 5 point something, which is 5. So this